All right, so in this one, we're looking at the power to a power rule, okay? And if you recall, when we were talking about with no variables, if we had a power to a power, for instance, if we had 2 squared raised to the third power, power to a power, you multiplied the exponents. So this would be 2 times 3 would give us 6, okay? So we multiply the exponents. Okay, so we're multiplying the exponents, but in this case, again, the coefficients here don't have an exponent. But what you really need to pay attention to with this parentheses is you can almost think of this like it's a distributive property of sorts, where the exponent outside the parentheses is going to be applied to everything that's inside the parentheses. So what I mean by that is we can kind of rewrite this as 4 to the fourth. This guy is going to be raised to an exponent of 4, and then that's going to be multiplied to a to the fourth, but that a to the fourth is also raised to the fourth, okay? So in a sense, here you can think of it kind of like the distributive property, where both of these guys are going to be raised to an exponent of 4, okay? And then from there, we can simplify. 4 to the fourth would be 256, and then we'd have a to the 4 raised to the 4. Power to a power, we multiply, so we had a to the 16th, okay? Let's look at this one with the negative. The one with the negative, I want to look at it in a slightly different way, simply because it's a common mistake here with the negative. Remember, this means we have 2 of these bases of negative p to the fourth powers being multiplied, okay? So looking at this, what this really means is we have a negative p to the fourth times a negative p to the fourth, right? We have 2 of these being multiplied. Now, the reason I want to write it out like this is so that you can see what happens with the negative. A negative times a negative makes a positive, okay? So whenever we write our answer here, it's going to be a positive. These negatives are, when we have a negative times a negative, we get a positive. Our base p is going to remain the same, but now we're actually in that product rule where we want to add the exponents. So 4 plus 4 would give me 8. Okay, now notice that would also be the same thing here. 4 times 2 is 8, but I wanted to show you what happens with the negative. So when we square a negative, we're going to get a positive. Okay, let's look at number 3. Okay, so again, this would be like 3 to the fourth, and then we'd have x to the third raised to the fourth power. Okay, and then we could simplify that. 3 to the fourth, we'd get 81, and then we'd have keep our base of x. 3 times 4 would be 12. Okay, let's try number 4. Looking at this guy, this would be 2 to the third times x squared raised to the third. 2 to the third, 2 times 2 times 2 times 2 times 2 would give us 8. And then keep our base of x. 2 times 3 would be 6. Okay, then we have number 5 here. Okay, this would be 4 cubed, and then x doesn't have anything either, so it'd just be x cubed. Well, 4 cubed would be 64, and then we would just have x cubed. Okay, number 6, okay, we'd have 4 cubed again, and then we'd have n cubed raised to the third power. 4 cubed would be our 64 again, and then 3 times 3, we get 9. Okay, let's see what else we have. Yeah, let's go ahead and do these guys too, okay? So looking at this guy, we'd have 4 to the negative first, and then we'd multiply that with a negative x to the negative first raised to the negative first, and then we'd have y to the third raised to the negative first, okay? Now, when we're dealing with these negatives, this might be a good idea, again, to kind of treat it like we're over 1, okay? Because eventually, if we have a negative, we're going to flip things. Okay, so let's just treat it like we're over 1 for now. So we have 4 to the negative first. What's going to happen with that? Well, that guy is going to flip down. Okay, so now we don't have to worry about the 1 anymore because we're flipping that down. You could say it's 1 times 4, but we don't need to put that because 1 times 4 is still going to be 4. So the 4 is going to flip down, right? Then we have x negative 1 times a negative 1. Well, what's a negative times a negative? A positive. What's 1 times 1? 1. So this is x to the first power, and then we have y to the 3 times a negative 1 would be negative 3, right? Okay, so we're close to being simplified. Our 4 dropped down because of that negative. You could say it's 4 to the first power, okay? But really that's just going to be 4. So if we simplify this, x to the first power is just x. 4 to the first power is just 4. And then what happens with the y in the negative? Well, it also flips down, so we'd have y cubed, okay? Number 8 here, we're going to have 2 squared, and then we have x cubed raised to the second, and then we have y to the negative second raised to the second. So again, because we have this negative involved, I'm going to treat it like it's over 1 just in case we need to flip something. So we have 2 squared, which is 4. 3 times 2 would be 6. And then negative 2 times 2 would be negative 4. Okay? So again, this is why we have it over 1, is so that in this case, this y to the negative 4th needs to flip down. So we'd have 4 x to the 6th over y to the 4th. Okay? Couple more. Looking at this example here, we would have z to the negative second. We have x to the 0 raised to the negative second. And then we have y to the third raised to the negative second. Okay? So I'm going to put it over 1 because it looks like we're dealing with negatives, so we're probably going to be flipping things. Okay, z to the negative second, there's nothing to do there. It's just z to the negative second. I know it's going to flip down, but maybe we can leave this one on top for now, and you can flip everything at once if that makes it easier. So we have z to the negative second, and then 0 times the negative 2. Well, what's 0 times anything? 0. So this is just x to the 0. And then we have 3 times the negative 2 would be negative 6. Okay, well now we can start to simplify things. What happens with the ones with the negatives? Well, the z and the y are both going to flip down, right? Okay, and again, you could say that there's the 1 times that, but you don't have to put the 1 at that point. They both flip down. And then x to the 0, we could leave that on top, but what's x to the 0 power? Anything to the 0 power is 1. So this x is really just a 1. Okay, so this would be as simplified as we can get. And then number 10, okay, what we're going to have here, and this is going to be one of those where we're over 1 again. We have x to the negative third raised to the third, y to the negative third raised to the third, z to the negative second raised to the third. And then multiplying our exponents, we have x to the negative 9, y to the negative 9, and z to the negative 6. All over 1. Well, all of these are negative, so what's going to happen? All of them are going to flip down, and the 1's going to flip to the top. Okay, so everything's going to flip, and we're going to have x to the 9, y to the 9, and z to the 6. They're all flipping down, and that 1 flips to the top. Okay, so this would be our solution.